No one at this point. Congratulations for actually getting my last name correct. Not many people can do that, so must be some Ukrainian blood in there a little bit. It's a hard one to pronounce. So just have a quick agenda. Start off with an introduction about myself, talking about why TypeScript and kind of why we chose it. Then looking at a few awesome things, and then a segment at the end for questions, where I promise there's a photo of me in a wizard costume. So, you know, something to look forward to for all those people. So my name is Phillipchuck. I'm one of the team leads over at Punchcard Systems. There's a few of us around. We do IT consulting and app development, kind of focusing on websites and custom web apps, mobile apps, document portals. We're moving into various different Microsoft stacks as well, looking at like the Power Platform, so Power Apps, Power BI, Flow, which strangely doesn't have Power in front of it, but Microsoft's always been bad with names. We're also hiring, which is, short plug. So come find me after if you want to talk about jobs and stuff. And that photo on the left is in most of our applications. It's one of my favorite pieces of debug data because it has a location on it, and it makes me laugh every single time I see it. So that's always good. So I'll start with what is TypeScript, because there's a lot of buzz around it because JavaScript is just so big in so many different spaces, and TypeScript seems to be the thing that everyone is talking about, but not many people are using it in production. And we are, so I just kind of figured I would go over what TypeScript is. So it's a superset of Java that brings strong typing and various different ECMA script features from some of the more modern releases and transpiles that down to a more compatible version. So it's a great way of taking some of the more advanced JavaScript features and kind of porting them wherever you want, as well as the thing it brings that people are most interested in, which is strong typing. It's also open source, which is great if you want to dig through some incredibly complicated code. It's important for a lot of people, and it's great that Microsoft has kind of a commitment to doing more open source projects, especially one that's for a community as famously free range as the JavaScript community is. I think it was kind of, if they were going to constrict people to types, they kind of had to make it open source, or else there might be kind of a rebellion. It's also strongly supported with some really excellent documentation by Microsoft. The docs at TypeScriptLang.org are phenomenal. It's also really strongly supported by a variety of different JavaScript frameworks, including Create React App and React.js, some support for Create React Native App as well. In addition, the Angular CLI, the more modern versions use TypeScript, and then Vue and Ember. I think Ember is moving towards it. They've stated that they're starting to use it more internally, but Ember, unlike some of the other languages, doesn't want to force people to use TypeScript as much as, say, Angular does. It's a lot harder to decouple TypeScript from Angular. So TypeScript is not overly burdensome to develop for. It really depends on how strict you're setting your standards in your tsconfig files. You can just rename all your JavaScript files and then use an extension to get some elements of TypeScript in your IDE. It doesn't necessarily need TSC you don't have to run through it in your build tools. Obviously, that's where you get a lot of the benefit of TypeScript, is bringing in those kind of strict checks. And it's also not incredibly complicated to convert from JavaScript. You can start using TypeScript across your entire program and just start bringing in features as you see it. Obviously, a lot of the benefits from TypeScript come from kind of rigorous adherence to their principles. Like if you bring TypeScript in and you type everything as any, which is just kind of like a wildcard, it loses a lot of the benefit because then you don't get the tools in development that really give you that advantage. And it's also not hard to find types for third-party libraries. If you have a node modules file with thousands of different third-party plugins, it's more people than ever are choosing TypeScript and are providing types as well. There's also a Definitely Typed, which is an excellent resource for providing types for third-party libraries, either libraries that haven't been updated in a while or libraries that aren't necessarily concerned with TypeScript. So it's got a lot of support, and the community is definitely moving towards some form of TypeScript support in most JavaScript most JavaScript kind of spaces. So why does TypeScript really matter? Well, it really brings clarity to your code in an immediate way than patterns or documentation. It brings a lot of that problems with figuring out how something should be into your code rather than out of your code. Everyone kind of hates looking at something with Javadoc with 10 lines of comments explaining to you that you have to feed a number to this particular method. TypeScript brings all that inline in a way that is really unobtrusive to people who are more used to kind of a JavaScript situation. And it also allows you to annotate your code in such a way that the impact of your decisions, if you have a piece of code, are made obvious to everyone. Everyone has probably had the circumstance where someone who is related to your team but not on your team has changed some element, whether it's on the front end or the back end, and then things just don't line up. The classic kind of example is someone changes how your IDs are set. So you have starting with numbers and you go to GUIDs and someone makes a change, doesn't inform everyone, and then suddenly everything just dies. With TypeScript, if you're generating your types in a way that makes sense, you'll immediately start to get those warnings and compiler issues saying, hey, you can't call this on this type doesn't work. And so it's just a little bit more safe, and it's a nicer environment. And why would you use types at all? It's a kind of a common question. It really improves your ability to read your code. Everyone complains about foo and bar and var a and const, test. It's kind of impossible to remove those from some circumstances. Like, it's hard to develop without that shorthand, especially when you're creating something new. But with TypeScript, you can at the very least be confident in knowing what things are. It saves you from having to look at all aspects of a particular file in order to figure out what you're working with. And it really helps someone who may be fresh to a product or a company figure out the general structure of how they should be working in whatever your environment is. It also really helps with refactoring. If you've ever had to change a long-living programmatic structure, it's really helpful if you can get those compiler warnings right away. There's lots of really great IDE support as well in terms of great extensions that will, in VS Code, underline anything that has errors in it right away, so you don't even have to get to the process of actually building it. As you're writing it, it's almost forcing you to maintain to whatever standards your company has kind of agreed to. And it's also easier to see like code analysis, figuring out, should this be any type, should this be stronger typed, and in the spectrum of typing from any down to a specific type, it also allows you to figure out the impact of your decisions, as well as it just prevents anyone from treating a number like a string or a string like a number. We use triple equals everywhere just to avoid these sort of things. What if there was a better way? TypeScript. So that's kind of my several thousand-foot view of why you would use TypeScript. I suspect there'll be a lot of questions as to how people can use it and like what the actual concrete benefits are, but I kind of wanted to go over quickly some examples of things you can do in TypeScript. And the first I wanted to look at is generics. So you can, with generics, define functions that are going to be applicable across multiple different types. So the classic example in other forms of programming is a print function. You want your logging or print functions to be agnostic of the type that you're providing to it. So generics allow you to specify a typed function without limiting it to numbers or strings or whatever your domain types are. So for example, if you want a linked list that accommodates any type you want, this code on the right-hand side from the TypeScript documentation will provide a linked list that allows you to progress down it without any additional information. So you can see it's got a type. Its type is linked list, and then it has the generic type. And it is just simply appending a property to it saying that I expect there to be a next property in this list that has the same type originally. You can get more advanced with this to support additional types, but this should kind of hopefully demonstrate a little bit of the power of TypeScript and also its flexibility. A lot of the problems I hear from people talking about TypeScript are that they don't want to get locked into specific types, and they want to worry about, are we adding boilerplate to every single function and every single method and every single class just to try and add some typing to it. But generics are a great way to kind of remove some of that typing, just to kind of give power back to people in JavaScript who are used to just writing whatever they want in files and letting everyone else kind of clean up their mistakes. The second thing I wanted to get to is utility types. So utility types are types that allow you to extend your own type. So it's not only it's defining a people and things and return types and different data structures. It also allows you to modify those so that you can work with them without individually writing a new type every single time. If you wanted to change how a particular type is requiring data, for example, you can use read-only or required to change how it interacts with its own properties. Read-only being that it will give you warnings if at some point someone takes your perfect data type, for example, a default location for a GPS map that you don't want developers to edit at runtime, and it'll give them warnings before they even try and get that into any sort of source control. If you're trying to edit any fields in it, it'll immediately return with errors with them, so you can prevent those errors from ever happening. Required also allows you to make sure that when you have initialization, that you're initializing data in a way that makes sense. So if you're requiring a date created field on whatever DTO you're setting to the server, this is a way of kind of just making sure that those fields exist before you even get to the part about actually sending it to the server. Two other ones I wanted to look at are kind of two related ones, which is pick and omit. Depending on how complicated your domain is, you might have these incredibly massive types that have hundreds and hundreds of properties and methods. And pick and omit allow you to either compose or exclude your types to generate something that's a little bit more user-friendly. So if you have a user type that has a bunch of personal data in it, say you're dealing with regulations like HIPAA, and you want to make sure that in this particular part of your application, no one is getting information to medical records or social insurance numbers, you don't have to create a new type. You can instead use the utility type pick to grab specifically the fields you want, or omit to kind of get rid of those. It really promotes reuse and refactor, because if then someone goes into that original base type and changes IDs to strings, then it doesn't break all of your other types. You don't have to worry about making differences in a bunch of different interface declarations. You can kind of use it once and really kind of fire and forget with it. And there's a lot of utility types built into TypeScript. Like non-nullable, for example, you can force if you have if you allow nulls on your properties, on your types, you can enforce them to be non-null. There's also, trying to think here, there's also record for composing data sets really easily with your types to be like, I want to have a quick dictionary of whatever my users are or whatever DTO I'm returning. So there's a large amount of utility types that allow you to really kind of make your types really flexible. And I mentioned that there is a desire for people to make sure that they're not just continually writing interfaces. Like every time we add something to JavaScript, there's always the immediate response is, doesn't this make me slower? Doesn't this add more burdensome to it? Like if anyone's worked with Redux, for example, there's always concerns about boilerplate in Redux versus context or something that's just a little bit more lightweight. And TypeScript also is pretty intelligent with the way that it can infer types. I'm not sure if that's incredibly readable over there, but we have an initial state for a React component. And rather than writing an interface and then casting your object to that type, you can simply infer it from an object. So this kind of promotes that sort of greenfield development that JavaScript is famous for, just flying by the seat of your pants and just going and getting everything done. By having a complicated objects in the initial stages and just generating your type from it and then consuming that type later in a component. That's pretty powerful because it means that you can change the entire scope of how your data looks without rewriting your interface files and then making sure that that also is reflected in whatever components you're using it in. Obviously, it's better to separate out into a clear interface declaration because it makes really explicit to your developers what the terms of that sort of typing contract are, but this is a way to kind of keep some of that dynamism that JavaScript is famous for, while still giving you the ability to have this file not be 60 lines, but be 3,000, which if it is, please refactor. But it allows people to come in and to extend your files quickly and easily without having to worry about where are the type files located? Are they ambient files that TypeScript is bringing in itself? Are they declared in this file? Are they brought in from a module? It allows you to be more flexible. And this next one is just a trick more for people who are working with TypeScript because any is not type safe, which can be a problem when you assign something to an any and it's a number and you call to locale string on it and suddenly it starts throwing you errors at runtime. That's not great. So unknown, if you have to use any, if you have to kind of abandon some of what TypeScript does really well, which is that strong type checking, unknown is just a better way of doing that. You can assign everything to it just as you would in any, but it prevents you from making those mistakes where if you assign an unknown to an object, it's going to throw errors because it doesn't know what that object is. It's basically a true type-safe primitive type. So if you can use unknown wherever you can, it's just your life will be easier. And as you're building all of these wonderful types together, there's also ways of composing them using all sorts of different features that TypeScript offers, including intersection types, which are really great. So if you have, for example, an iUser interface and an authenticated interface, perhaps that have some information on it, so we're talking username, email address, but then also things like access tokens, refresh tokens. If you want to compose them together, you can use intersection types to kind of grab everything and kind of smush it together. So you don't necessarily have to build out your types in such a way that you're accommodating for every circumstance. You can combine them in ways that other languages similarly allow you to do, which again promotes that idea of refactor and reuse, because if you write something, it's very unlikely that no one is ever going to revisit that. And the easier you can make someone else's job, the less you have to worry about hiding where you work in an office, because then people won't try and hurt you. And the kind of last type that I wanted to kind of look at, again, this is supposed to be kind of a 4,000-foot view of TypeScript, is the union type. So this is also very common where you have something you want to make agnostic, but there's drastically different ways of handling something. So if you wanted to pad something, if you're padding a number and padding a string, drastically different ways of dealing with that, but you don't want people to pad an image or to pad a date necessarily. You can restrict it to only set numbers of types, which allows you the flexibility to really ensure that anyone who works with your code, or even yourself, because we've all looked at files we've written even 2 days ago and just kind of, I have no memory of this place, right? It saves you from making those mistakes that we all do. Like we could try and pretend that we're all perfect, wonderful programmers, or we could work with a framework that allows us to truly protect ourselves and our fellow developers with whatever weight you want. Anyone who tells you that there's a right way of working with TypeScript is wrong. It's just however works with your company. You can provide as much security or as little as you want. And it's kind of the wave of the future. So that was probably less than you want. Promised you a photo of me in a wizard costume. Yes, I LARP. I know, I'm a nerd. So does anyone have any questions about TypeScript? And I will try to answer those as best I can.
You know the most hated dark corner of TypeScript where the typing system just doesn't work for you?
I will say that the typing system, if you are applying it universally through your team, it's okay. I will say that the hated corner of TypeScript is probably its integration with build tools. It works really well with Webpack, and they have tutorials for other different systems, including like Gulp or whoever you want to get your files out there. I will say that most of the problems I've had with TypeScript are on integrating it with some other JavaScript thing. And the thing I can think of most commonly is Expo, a React Native wrapper that provides an easier way of building React Native apps. That was kind of a nightmare to get working with TypeScript, and it wasn't perfect in that it was compiling and running, but we had to debug using the transpiled JavaScript files, which if you haven't looked at anything that's gone through that sort of process can be kind of nightmarish, especially when you're converting JS 2015 features down several versions. You see all of the ugly work that goes into doing that, and it's harder to debug. But when we switched to the React Native CLI, that process was almost perfect. So any space that's reasonably robust to have solved those problems for you which is always great. It works flawlessly, and if it doesn't, it can be kind of annoying to get to that space. Yes, in the back.
Awesome. So what do you do with libraries or modules that don't have like good typing? Like I've used like I want to use like a React command from someone else, but it definitely types doesn't have it, or typing's just like stuck.
Great question. I'd love to say that doesn't happen, but it definitely does.
Can you summarize with a video? Just like the question.
Oh, yeah, absolutely. So the question was, what happens if you are wanting to use a JavaScript module that doesn't necessarily have that strong typing support in a project that's using TypeScript? I'll say that if it's October, you should contribute to definitely type a brand new typing file for that third-party library. But that's not always in the scope of a project. It really depends on how specifically you have your TypeScript set. So it will either complain if no types are available, or you can use just any JavaScript you want inside of TypeScript. Because remember, it is a superset. So all JavaScript is valid TypeScript. You could just have the dirty corner of your application that references something that's not strongly typed, and you just kind of have that tacit contract with the rest of JavaScript, as we all have, that like, hey, I'm trusting you to actually do your thing here and to actually have good documentation. So you could also write your own ambient type files if you just wanted to kind of use that. We do that for a few of the libraries that we've used that don't necessarily have typings for it.
It's a lot less of an issue than it used to be.
Yes.
People who worked with TypeScript years ago and then like gave up on it don't know that like the third party support has gotten way better.
And it's even started to become first party support for a lot of major JavaScript libraries. So there's a lot less definitely typed type definitions in our projects than there were even a year ago. People are really recognizing that with just a couple hundred lines, only speaking in the matter of JavaScript libraries, you're not going to be writing hundreds of lines of types if you don't want to. They can provide a lot of benefit for their users because it's definitely kind of, and again, this is subjective because we do use it and we're not going to stop using it, but we think it's where the winds of change are moving to in JavaScript. Sorry, there was another question right there.
So I noticed you used the partial utility a few slides back.
Yeah.
Yeah. What is the partial utility?
The partial utility is basically exactly what it sounds like. It is defining.
It sounds like.
It's defining a subset of a type. So it's related to like pick and omit. There's a lot of different ways to get a partial version of it where it's like I need these elements but not these elements from a particular type, where you have a user but you don't care about where they are located, for example. So that's it might be used to generalize API returns where you might have like a detail view and a list view. So you have a type that says, here is the type that perfectly encapsulates everything about a course in school. And then you have a partial type of it in the list view because nobody cares where it's located in the list view. They want to know how many credits is it worth, who's teaching it, that sort of thing.
So does it mean that like every property therefore is a union of the property itself and undefined?
Sort of. It really depends on how you are. I don't know the specifics of the internals of that. I believe it's creating a brand new type that excludes it completely. But I could be wrong about that one because I have not used that utility type in production yet.
I'm pretty sure it just marks every property as optional.
Optional?
Okay.
I thought that was non, is that?
I think that's partial.
Okay. Learn something new every day.
Sure, but I think.
Well, we have like a couple of tacit thoughts there. So maybe the answer is we should probably read the documentation before we provide you a firm answer that you base the next Slack on. So I don't want to be responsible in 10 years if there's a security flaw.
So JavaScript typically suffers from stringitis, where everything is a string even though it shouldn't be. You gave an example using GUIDs. How would you go about using TypeScript such that GUIDs were actually type enforced yet still string?
Well, you can generate your own type, and at that point, and you can. It kind of feels like something that should be a class almost at that point, because then as you're initializing them, you can make sure that they're GUIDs and raise whatever warnings you need to. That's a good question. I would say that at this point, I'm kind of unfamiliar how you would handle it in a more complicated way than just as a string. That's something that I haven't really had to look into. Thinking about things like the separators involved in a GUID, enforcing like the right degree of kind of randomness that the standard has to adhere to. So that's a good question that I don't have an answer to, and I'm sorry for that. Yes.
I just want to add to that. The union types with strings, like this kind of solves the, it alleviates the stringitis. Where
Yeah.
you can say, hey, my variable is going to be exactly these 3 strings.
Exactly. Yeah.
It's like an email.
Yeah, and I suppose that provides an extremely hackish solution where you could just union every possible GUID together, but I'm not doing that. So seems like an anti-pattern. Throwing that out there. Any other questions? Yes.
One thing I found is when you persist data, you run into issues with types trying to like bring them into your type system, and schema migrations and all that fun stuff. How do you? And it brings me back to like Java years where you have these things that are like not like bringing stuff into your type system from the data persistence layer. How do you deal with that?
The great answer for that is that we use ServiceStack, and because it's a message-based framework, we have kind of message requests that get sent back and forth, and we define what goes in and what comes out. And ServiceStack has a great feature where you can hit an endpoint on a running production server of ServiceStack, and it generates your types for you. So that solves the problem of some backend and database wonk changing some fields or adding them and causing errors in the front end, getting rid of fields you might rely on. If you put it as part of your build process, you can automatically pull those types, and then as you're updating your ambient declarations.
Data already exists, like that's persisted, like customer records that are in version 1 of your schema.
I don't know if TypeScript has a distinct way of solving that, because that feels like it's larger than the scope of TypeScript. But I could be wrong about having migrations. I don't know of any like versioning tools to help that other than kind of working with it in a rigorous structured manner.
I guess a similar thing is how does TypeScript serialize to JSON? How is that at least reasonable?
I mean, it's just like a JavaScript type, right? So everything is just, it's running, it's transpiled back down to JavaScript, right? So you're never running TypeScript files. So everything is just, like a normal JavaScript object. So it serializes just fine. There's no additional typing information available in it. It's more that it provides the rigorous protection at compile time. But if you were to go in there and modify some properties and change types, it's still going to cause errors. So if you go in the inspector and edit the files that you're working with, it's still going to break in that regard. So.
I think we better stop here to stay on schedule, but let's.
Cool.